bell work problem here, and similar to the problems that we saw before the weekend. First of all, find the missing length of a right triangle with the following sides. So we have sides of 4, we don't know, and 12. So if we use a Pythagorean theorem, we got to grab ourselves a little marker and do a little writing here. So we're going to have 4 squared plus b squared equals 12 squared. And then to find b squared, we just do b squared equals 12 squared, which is 144. And then we have to subtract a squared, which would be minus 16. And so 144 minus 16, we'll use our calculator for that. So we'll have 144 minus 16 equals 128. So b squared equals 128. And then we're going to take the square root of both sides of that. So we get b equals the square root of 128. And we'll leave this one in radical form, but you could take the square root of that and get a decimal and round it. So it's going to be somewhere 11 point something. Okay, so on number 2, if we're supposed to find the area of the missing square over here in this diagram, well, we've done one like that before. We know that a squared plus b squared equals c squared. So the area of this square up here is basically 16 plus 36. So that's 46, 47, 48, 49, 50, 51, 52. So this is 52 centimeters squared. There you are. So that was pretty easy. Okay, name the side of the triangle that is opposite the right angle. So if I have a triangle and I have a right angle like this side over here is called the hypotenuse. It's got kind of a weird spelling, Hypotenuse. All right, moving right along. Find the length of the diagonal of the given rectangle. So we're trying to find this. We're going to call this side C. So we know that a squared, or 8 squared plus 12 squared equals c squared. And 8 squared is 64. 12 squared is 144. So we're going to add those two together with our handy-dandy calculator. So 64 plus 144 equals 208. So c squared equals 208. So we take the square root of both sides, and that gives us c equals, and we'll go ahead and do this one on the calculator. So we already have 208 on the calculator, so if we take the square root, we get 14.42205. So we will round it to the nearest hundredth, which would give us a number of 14.42. So 14.42 inches. Okay, so now that we're getting really good at the Pythagorean theorem, we'd like to solve a few word problems today to kind of help us, see how we might use it in real life. So here's a sample problem. The bottom of a ladder must be placed 4 feet from a wall. The ladder is 14 feet long, and how far above the ground does the ladder touch the wall? So if you notice, if you have a ladder leaning against the wall, and you look at the lines, how far the ladder's base is from the wall, and then the length up the wall, you actually form a nice little right triangle right there. And they told us that the bottom of that, the distance from the wall to the ladder is 4 feet, and the ladder itself is 14 feet long. So we're going to be looking at this h, which when we use the Pythagorean theorem is going to be a or b, however you write them. So let's go ahead and write that out. A squared, we use one of our little shortcuts, is going to be c squared minus b squared. And 14 squared, that's going to be a little tougher. I know that 4 squared is 16. So what's 14 squared? So 14 x squared is 196. So 196 minus 16, so we end up with a squared equals 180. Then we take the square root of both sides, and we end up with a equals, and the square root of 180 square root would be 13.42. So 13.42 feet up the wall. That's how high up this ladder would reach, is up to that point right there. So pretty good. All right, let's try another one. What is the length of the diagonal of a 12 centimeter by a 9 centimeter rectangle? So basically what they're saying is we have a 12 centimeter long, 9 centimeter high, or you could reverse that. And we want to know how long is the diagonal of that rectangle. So if you notice, we got a nice little triangle. We're looking for, oops, we better grab the right marker here. We're looking for C in this particular case. So we got to find C up here. So to do that, we do a squared, or 9 squared, plus 12 squared equals c squared. 9 squared we know is 81. 12 squared is 144. And all of that equals c squared. And then we'll take the square root of both sides. So get our calculator. We've got 144 plus 81, and that equals 225. 225 equals c squared. And then when we take the square root of both sides, we end up with c equals, and the square root of 225 is 15. 15 is what we're looking for. Okay, moving right along. In an advertisement, a computer monitor is listed as being 18 inches. 18 inches, what does that mean? The distance is the diagonal distance across the screen. If the screen measures 10 inches in height, what is the actual width of the screen to the nearest inch? So basically what we're doing is we're imposing a triangle on there, and we're saying that this distance right here is 18 inches, the diagonal. And the screen itself, its height is 10 inches. So what we're really trying to find is how long the base is, or how long it is across here. So we're looking for B. So let's write out our numbers. So we're going to have B squared equals C squared minus A squared, which is 10, right? Okay, we know what 10 is. 10 squared, that's 100. So let's find C squared. So we've got to square our 18. So 18 x squared is 324. And all of that is equal to B squared. So when we take the square root of both sides, we're going to end up with B equals the square root of 224, which equals, and if I get my calculator going, I put in 224 square root, I end up with 14.97. So 14.97 inches, almost 15 inches wide. But remember, from here on out, when you hear that you have an 18-inch monitor or a 36-inch monitor, they're talking about this diagonal distance from one corner down to the other corner. Okay? So how about this one? We've got a basketball court that's a rectangle. It's 60 meters wide and 75 meters long. So 60 meters wide, 75 meters long. The coach asks the players to sprint from one corner of the diagonal to the other one. What is the distance the players run? So let's go ahead and mark that out. We got this diagonal right here. Okay, so, well, the way I've drawn that picture, we have to kind of visualize again that this distance over here is also 60. So we know A and B. So we're looking for C, which is the diagonal. So we've got A squared, so 60 squared plus 75 squared equals C squared. And get our calculator running. 60 squared is 3,600 plus 75 squared, that's going to be a pretty big number. So 75 squared, that's 5,625. Now we're going to add that to the first number. So 5,625 plus 3,600, and that gives us a total of 9,225. So 9,225, and that equals C squared. So let's do our square root. Square root of 9,225 is 96.046. So it's going to be 96.05 feet. So C equals 96.05 feet. And that's that distance right there. 96.05 feet. All right. It's not looking too bad, is it? Okay, so what if we get a problem like this? An isosceles triangle has a congruent sides of 20 centimeters each. The base is 10 centimeters each. Find the height of the triangle. So basically what they're saying that you need to do is divide this in half, create two triangles out of it, and then you're going to find the height of the triangle. Now you got to keep in mind you got some of the measurements here. If this originally base was 10, then that means each half is going to be 5. And then if each of the sides, up these sides is 20 and 20, and that's 5, then you can either use this 20 and this 5, or this 20 and this 5 to find the height, which is A. So then basically we have A squared equals 20 squared minus 5 squared, or A squared equals 400 minus 25. I'll skip to 100 there, or a 0 there. So the square root of 400, well, 400 minus 25 is 375. And now we'll take the square root of 375. So we get on our calculator and do 375 and the square root, and we get 19.36. 19.36 centimeters. And that's what you get for A after you take the square root of everything. So there you go. All right. So I think we can do a few of those. So today's assignment is actually going to be on Alex, and then tomorrow we're going to give you a worksheet that looks very similar to it as well, to give you a little practice, or vice versa, so you can practice on both mediums. Thank you very much.